So hello everyone, welcome back to another particular lecture of our reagent chemistry course, and this is class 16. And in this particular class, we are continuing our discussion regarding the organometallic reagent. So in our previous two classes, we are talking about Grignard reagent and Gilman reagent in details. So today in this particular class, we talk about the organolithium reagent in brief. So first, organolithium reagent has been written as like RLI, and this particular reagent is generating that R minus nucleophile, and this particular R minus nucleophile is hard nucleophile due to presence of this particular lithium, and this particular nucleophile is more harder nucleophile than Grignard generated nucleophile, because lithium have the more charge density over magnesium, and that's why this particular nucleophile is much harder. Now, how to prepare this organolithium reagent? Now, organolithium reagent can be prepared via metal halogen exchange reaction, such as this is the alkyl halide. Alkyl halide react with the lithium, then the one of the lithium is exchanged with the halogen here, and we got our metal halogen product. This is the RLI. This is the nothing but organolithium reagent, and LiX. This is the salt, and the X should be chlorine, bromine, iodine. Chlorine are not used to synthesize organolithium compound, because what happened that if this is fluorine, then ortholithiation takes place. So we'll discuss in the later. Now here also this is the bromine. Here metal halogen reaction takes place, and we got our organolithium compound with LiBr. Now different reactions, like organolithium shows two type of reaction. One is the ortholithiation, and one is the nucleophilic attack on the carbonyl compound. And this particular is similar like Grignard, because both are the hard nucleophile. That's why both are showing 1,2 addition. Now first let us talk about the ortholithiation in brief. So ortholithiation is if there is a directing group is here, then in presence of this particular hydrogen, ortho position hydrogen has been exchanged to get this type of product. And these are the nothing but ionic type of product. This is called the ortholithiation. So which groups are actually triggered the ortholithiation process? When Z equal to OR, OCO-CH3, SO2-PH, OCO2, OMe, NMe2, CH2, NMe2, these type of groups, especially the electron withdrawing groups, these are actually shows that ortholithiation in this particular part. And this is not the final product, this is acts as the intermediate, because this particular will undergo different kind of reactions. Like here, then ortholithiated compound, this thing shows different reaction in presence of different electrophiles out there. Like this particular thing will react with any kind another alkyl halide, show a coupling reaction, something like this. Also, it will react with this type of compound as a nucleophilic addition, and we got our final product this. Similarly, this ortholithiated compound can react with the epoxide and the attack from the less hindered side, and this particular bonds open up, and we got this type of compound. So it has this particular intermediate has important significance in organic synthesis. Now let us talk about nucleophilic attack on carbonyl compound. As we discussed already, that since the organolithium is generated, the R minus nucleophile, which is hard in nature, and thus this show similar reactivity like Grignard reaction. Like here, that organolithium react with the CO2 will get this ketone compound. This is the important exception over Grignard reaction, because Grignard will directly generate it to acid, but here it will generate it till the ketone part also. It will react with acid chloride. This 1,2 attack takes place and the chlorine kicks out. Initially, it will generate a ketone, and after that, a more concentration of the organolithium compound will lead to finally the tertiary alcohol. Similarly, it reacts with ketone to get that tertiary alcohol, react with aldehyde to get the secondary alcohol. Excess amount of organolithium can react with ester to get the tertiary alcohol, react with veranopamide to get initially a ketone compound. After that, it will again go for a more reaction to get the tertiary alcohol, and cyano are also give the corresponding ketone compound, and epoxide it will show less substituted site attack, this R1, and it will epoxide opening takes place. So similar kind of reaction has been observed between Grignard and organolithium. Just this particular reaction is a exception one. It is written here that similar reactivity like Grignard reaction. Now let us give some more examples regarding the organolithium reagent. Like here, this is the product where the halogen is there. So when the halogen is present, then a metal halogen exchange reaction has been observed. So here metal halogen exchange reaction is observed, and then this particular negative charge will show nucleophilic attack to here to get our final this particular product. Also, if we add here H2O and H plus, that means acid hydrolysis, then we got only furan. This is the important reaction, you have to remember this thing. Also, if you have this type of compound, then always remember that ortholithiation takes place on the ortho position of the electron withdrawing group. Like here or here, this two is the ortho position, but since this is the electron withdrawing group present here, that's why this particular ortho position is not used, and this particular ortho hydrogen has been abstract by the or exchanged by the lithium, because there is a possibility of chelation between this particular electron withdrawing group and lithium. That's why this particular product is the final product. And here in this particular, both are the electron withdrawing group, and both ortho is this particular position is the ortho of the both NO2 group, and that's why this particular product is the major here in this particular reaction. Now let's talk about some more substitution reaction. That this is the electron withdrawing group. So here the ortholithiation takes place, and after that this particular negative charge will attack here. This particular bond goes up, this goes down, and chlorine is kicked out, and we got final this product. Similarly, here also the similar reaction has been observed, that the ortholithiation initially takes place here, and then this particular negative charge will attack a 1,2 addition with the carbonyl carbon here, and this particular negative charge will go intramolecular reaction and to kick out this particular ester part, and we got this product as a final product one. So with this we have to end this particular lecture. So in the next lecture we are talking about the organoboron reagent. So thank you for listening.